First hop redundancy protocols like HSRP, VRRP, GLBP, they're great because they allow us to have some redundancy on a network for default gateways. Your PC, it's configured with a default gateway, but if that default gateway goes down, how do you get off your local subnet? Well, with a first hop redundancy protocol, we can have another router step in and take over. And we want to consider in this discussion HSRP. And HSRP is it's a Cisco proprietary first hop redundancy protocol, and it's going to allow us to have a couple of routers, one active and one standby, and they can be keeping an eye on one another. They're exchanging hello messages, and if the hello messages cease from the active router, then the backup router can take over and it can actively start forwarding packets off of our subnet. However, sometimes we want to have that standby router become active, not just because it's no longer receiving hellos from the currently active router, but maybe something beyond the active router has an issue. Let me sketch this out for you. Let's say that I've got my active router, I've got a standby router, I've got a switch in the middle, connected to an end station, and let's say that this is currently let's say that this is the active router, and this is the standby. And maybe we have the internet or some other WAN connection. Let's say that something bad were to happen to this router or to that link going from the active router out to the internet. If something bad were to happen, even though, can you see that this active router, it's still able to send hello messages to the standby router? Can you see that if something bad happens upstream, if we have an issue right up here, that should no longer be the active router. It's not able to get us to the internet. And we can monitor things like whether or not an interface that goes out to the internet is up or down. We can measure things like the metric to reach a certain destination network. And we could say, I want to decrement my current priority if a certain condition exists. Remember, with HSRP, a higher priority is preferable. The default priority is 100, and usually we'll go in and we'll inflate the priority of the router that we want to be the active router so that it will become the active router. And maybe that active router normally has a priority of, well, let's say it's 150. Let's say it normally has a priority of 150. Maybe the standby router has a default priority of 100. But if something bad happens in the network, if there's some network condition like this, we might want to decrement this priority by maybe 60. That's going to give us a resulting priority of 90. If we have that reduced priority, then the standby router, it can take over and it can suddenly become the active router. What we want to do is consider some troubleshooting scenarios around what happens when we're tracking something beyond the active router. It's called enhanced object tracking, and we're specifically going to consider an interface's IP routing state. We're going to say if this interface is able to route IP, great. We're not going to decrement our priority, but if it's suddenly unable to route IP, we don't want to use it. We want to decrement our priority at that point, and we're going to consider issues that might cause this to fail. For example, that IP routing simply may not be active on that interface. Maybe it's not up. Something's not plugged in perhaps to that interface, or maybe the interface does not have an IP address assigned to it. Let's take a look in the live interface at how to do a basic configuration. We see an example here on screen, but I want to take you out to the live interface and let's walk through the configuration of an enhanced tracking object. So first of all, notice on screen we're tracking whether or not gigabit 0/0 is able to route IP traffic or not. And if it's not, we're tracking this tracking object is 1. We're going to decrement our priority by 20. But I want to show you this out in the live interface. Let's get started with our configuration here on router R1, and let's create our tracking object, our tracking rule. Let's go into global configuration mode, and I'm going to say track 1, and I'm going to be tracking interface, and let me show you the interface identifiers. I'm going to be tracking interface fast Ethernet 0/1, we'll say, on R1. Let's track whether or not it is able to route IP. We'll say, actually not trace, I want to say track 1 interface fast Ethernet 0/1 IP routing. And we could track a variety of things. Routing, there we go. We could track a variety of things. Here I'm just tracking whether or not this interface has the ability to route IP traffic. Now let's go into interface fast Ethernet 0/0 and configure it for HSRP with object tracking. It already has an IP address. I'm going to say standby 1. That's our HSRP group number, and I'm going to say that our virtual IP address that we're servicing is 10.1.1.100. And I'm going to say that our priority is higher than the default of 100. I'm going to say it's 110. And I'm also going to give the preempt option. Let's talk about the preempt option for a moment. I'll say standby 1 preempt. This means that if I have a superior, if I have a higher priority value, and I lose my status as the active router, if I go down and then I come back up, for example, or if my interface goes down and comes back up, if I have a superior priority value, I will reassume my active role. That does not happen by default. We could be the active router, reboot, come back up, and even though we have a higher priority value, we're still not going to be the active router if we don't configure this preempt option. But here we are configuring the preempt option. Now let's link this to our tracking object. I'll say standby 1 track, and we're going to track object number 1. What are we going to do? We're going to decrement by 20. We're going to decrement our HSRP priority value by 20 if we have a value of false, if you will, if we're not able to do IP routing on that interface that we're monitoring.